This video is to help you prepare for the objective check for FN1 through FNC over functions. So these are all questions from a practice objective check for FN1 to FNC. And here's our note. The following problems are for personal review or study purposes only. They will not be graded, so please do not attach work to these unless you are practicing that function. So for FN1, which is determining if a table, a set of ordered pairs, if that is or represents a function, and identifying its domain and range. So here you have this table. We have the x values are 8, 9, 13, negative 18, and 12. The corresponding y values are negative 4, 11, 14, minus 20, and minus 6. So the domain is the set of all x values. So I'm going to go down here and just write down the x values as a set. So the set containing 8, 9, so 8, 9, 13, negative 18, 12. The one thing to remember is that we don't repeat values. We don't repeat values. So if an x value shows up more than once, we don't include it more than once. And in the range, if a y value repeats, we don't write that twice either. So the y values here are negative 4. So I'm going to say negative 4, 11, 14, minus 20, minus 6. Is the relation a function? Remember, the definition of a function is that every x value has exactly one y value. Another way to say that is that our x values cannot repeat, and since none of ours repeated, this one is in fact a function. So yes. So let me say that here again. I'm going to write this. X values do not repeat. It means or implies this is a function. So if the x values do repeat, then it is not a function. All right, now for FN2, this is determining if a graph is a function. We have 6 graphs, and we want to use the vertical line test. Now I'm actually going to move to question 3 to help answer this. Question 3 is on the same objective, and you will see this question again. Why does the vertical line test tell us whether the graph of a relation represents a function? And these are all mixed up versions of this sentence. There's the first one is when a vertical line intersects the graph of a function more than once, it indicates that for that output there's more than one input, which means the function is not a relation. Okay. That's just the first one. I'm just going to skip to the second one. This is the correct answer. Go ahead and mark it that way. Why does the vertical line test tell us whether a relation is a function? The graph of a relation represents a function. When a vertical line intersects the graph of a relation more than once, it indicates that for that input, there is more than one output, which means the relation is not a function. So we're going to take a vertical line, and if we can draw a vertical line that will intersect our graph of our function or our relation more than once, then it is not a function. That's kind of like saying our x's repeat. So on the very first one, this graph turns back over itself. So I'm just going to draw a vertical line right here. This would cross that relation twice, so therefore this is not a function. Now this question says select the graphs which represent functions, so I'm not going to mark that one. The next one, going across, is a circle centered at 1, 1. With a radius of 1, and I could draw a vertical line right through it at x equals 1, and that would intersect this graph more than once, in fact exactly twice, so this one is not a function. For the third graph, we have a line with a slope of 1, and it goes to the point 0, 1, and if I start drawing vertical lines, you'll notice that I can't draw a vertical line that would cross this twice. Each line that I draw, vertical lines, only cross this graph one time. So this one is a function. I'm going to go ahead and check it. Next one we have is a horizontal line that crosses the y-axis of 1. And if I begin drawing vertical line segments across that, you'll notice again, every line segment only intersects that graph one time. So this one is a function, and I will mark it. Similar argument follows for these last two. If I draw a bunch of line segments. I can only ever cross this graph one time, so this one is a function. And then the very last one, similar thing happens. And I draw vertical lines, they only cross once. This one is a function, so I would check those last four. Now remember, on your objective check, the types of graphs are randomized, the location of the graphs are randomized, so there's also one other thing to pay attention to. Select the following graphs which represent y as a function of x. Those are our instructions. Your question could say, select the graphs which do not represent y as a function of x. So read that carefully. All right, moving on to question 4. This is for FN3, and that objective says that we can evaluate a function using variables. So using variables, using constants, and also do this with an equation or given a graph or a table. So there are two questions. One is evaluating with an equation. The second is evaluating with a graph. So to begin with, we'll work with this. We have the function f of x equals 7x squared plus 3x minus 8. And we want to find f of 0. So I'm going to come over here. F of 0 is going to be equal to, so to find f of 0, I'm going to replace every x value with 0. So I'm going to write down 7 times something squared plus 3 times something minus 8, and replace all those inside those parentheses, the something, with a 0. So 7 times 0 quantity squared plus 3 times 0 quantity minus 8. And using a calculator or just some mental math, you can see that this is going to be equal to minus 8. So f of 0 equals minus 8. That'll be our first blank of this question. Now next we want to find f of 2. So f of 2, following the same procedure, will be 7 parentheses 2 close parentheses squared plus 3 open parentheses 2 close parentheses minus 8. Now we want to evaluate that. So 2 squared is 4 times 7, that's 28. 28 plus 6 is 34 minus 8. I'm just going to go ahead and do this in a calculator anyways, just to make sure I don't make a mistake. But at the very minimum, notice that as I go through this, I'm writing the minimum amount of work. Actually, let me go look back at the last couple. There's really no work to display for FN1 or FN2. So even though there's an add work button, you do not have to show work for some of these. But FN3, you have to show some work. Let's see, that'll be 2 squared parentheses plus 3 times 2 minus 8. That is equal to 26. So f of 2 equals 26, and that'll go in our second blank. Third part of this is find f of negative 2. Following those same steps, I'm going to say 7 parentheses negative 2 close parentheses squared plus 3 open parentheses negative 2 close parentheses minus 8. Now, putting that into a calculator, that is equal to 14. So f of negative 2 equals 14. Now, the last two parts of this are to determine f of x plus 1 and f of negative x. These two may take us a little longer. So f of x plus 1 equals 7 parentheses, open parentheses, x plus 1 close parentheses squared plus 3 open parentheses x plus 1 close parentheses minus 8. Now first I would like to simplify the x plus 1 squared. If you remember, x plus 1 squared means x plus 1 multiplied by x plus 1. Two different quantities there. And then we're going to include the 7. So 7 times x plus 1 times x plus 1 plus 3 times x plus 1 minus 8. Now, I'm not going to go into all the detail on the foiling, as we would call it, for x plus 1 times x plus 1. But if we double distribute there, that becomes, in parentheses, x squared plus 2x plus 1. So that's 7 parentheses x squared plus 2x plus 1 close parentheses plus 3 multiplied by 3x plus 1 in parentheses minus 8. If I distribute the 7 to the first set, that will be 7x squared plus 14x plus 7, plus, and then I'll distribute a 3 to the second set of parentheses. That will be plus 3x plus 3 minus 8. Finally, I'm going to combine like terms. Okay, we have a 14x and a plus 3x. We also have a plus 7, a plus 3, and a minus 8. So we can combine the x terms. We have a 7x squared. It's the only x squared term. 14 and 3x together become 17x. And adding the constant, 7 plus 3 minus 8 is 2, so plus 2 at the end. That is the most simplified this is going to get, so f of x plus 1 equals 7x squared plus 17x plus 2. That's our answer for that fourth part. Now, the fifth part, f of negative x, will replace x with a negative x, so this will be 7 parentheses negative x parentheses squared plus 3 open parentheses negative x close parentheses minus 8. Now the difference here is that a negative x squared is a positive x. So 7 negative x squared becomes 7x squared. However, 3 times negative x will be minus 3x. And then we bring down our minus 8. So f of negative x is 7x squared minus 3x minus 8. And clearly that question does require some work, so be sure you submit the work for that one. Now, question 5 is evaluating with a graph. The first one was with an equation, second one is with a graph. And it says to evaluate f of negative 1. Now, we're given a graph, and I'm just going to read off some of the points that are on this. We have the point negative 5, negative 2. We have the point 4, and that's something like 3.5. The point negative 3, 5. The point negative 2, 4. The point negative 1, 2. The point 0, 0. The point 1, negative 1. The point 2 and point 5. The point 3 and 5. Those are just the visible points we have. Now, one of those points was negative 1 something. And if you were to listen back through those, it was negative 1, 2. Because f of negative 1 means the input, the x value, is negative 1, and the answer is the output. So when x is negative 1, y is equal to 2 for that ordered pair, so f of negative 1 equals 2. And as you can tell, there is no work to submit for that question. It's just something that you observe. But it's always good to include some reasoning if you're unsure of yourself, to make sure that you have some justification. That's really what it's for. Next we have FN4. Now FN4 asks us to do several things. One of those is determining the domain and range of a graph. But most importantly, it's finding where a graph is increasing, decreasing, constant, and where we have minimums and maximums, relative minimums and maximums. So this function, I'm just going to describe it. It begins by increasing from the left, and there are no arrows drawn, but we assume when a graph runs off of the edges of our bounds that it's extending to infinity in those directions. So this graph begins by increasing from the left up to the point 1, negative 2. So we have here 1, negative 2. We increase to that point. Then it decreases to the point 7, negative 8. And then from there it increases forever. Now the first part of our question says the function has a maximum of what at x equals what? Well, maximums occur when a function changes from increasing to decreasing. So as I was reading, I said it increases to this point, increases to 1, negative 2, decreases to 7, negative 8, and then increases forever. The one place where it changes directions, going increasing to decreasing, is the point 1, negative 2. So the maximum for that point is negative 2. So it has a maximum of negative 2 at x equals 1, because we had the point 1, negative 2. Now, the second part of this says the function has a minimum of what at x equals what? Well, again, a minimum occurs when a function decreases and then reverts to increasing. And as we were reading through this, it increases to the point 1, negative 2, decreases to 7, negative 8, and then increases forever. So the minimum is negative 8 at x equals 7. Now, the next thing we need to find is where the function is increasing, what intervals on which it's increasing, and then interval decreasing. Now, all we care about with increasing and decreasing is the x values, where those things happen along the x-axis. So I will read off my description one more time, and that'll be, I think, the last time. So it increases from the left up to 1, negative 2, so 1 is an important number. So it increases until 1. So the first thing I'm going to write here is parentheses, minus infinity, that's from the left, comma 1, close parentheses. That's the interval from minus infinity to the far left up to the x value of 1. Next, our function decreases from 1, 1, negative 2, over to 7, negative 8. So that is the interval parentheses 1, comma 7, close parentheses. Then our graph increases again from 7, negative 8 to the right. So that would be the interval parentheses 7, comma infinity, close parentheses. And that's an interval of increasing, so I'm actually going to put that in that increasing box. Now, because there are two intervals, I'm going to put a union. Okay, that's a capital U you can type, or in the toolbar there's an actual union symbol, but it looks like a U. And that describes all of the increasing and decreasing behavior. There are no intervals where this is constant, so we don't worry about that. Now, the next part of this is find the domain and range. Now, as I was describing this, I was indicating that it goes to the left forever, and it goes to the right forever. Okay, because there are no bounds in the x direction, the domain is going to be parentheses, minus infinity, comma infinity, close parentheses. Domain is all real numbers. It extends to the left and right forever. Now, also in my description was that it increases from below, okay, so from the left and below. So that indicates that there is no lower bound. So it's going to be minus infinity on our range. And also on the right-hand side of this, it increases forever. So my range will be minus infinity, comma infinity, in parentheses. Now this is another question where there is no work to be shown, so you don't need to add work to this unless you'd like to include justification for what you did. All right, so our next objective is FNA, and that is determine if a function is even, odd, or neither. Now we have the equations for each one of these given as well, but we also have graphs. Now, how we tell that a function is even is if it is symmetric about the y-axis. That is, that the y-axis splits this into two mirror images. Now, I have three functions displayed, and I'm going to leave it to you to look at those. But the far right, that's my question 9, okay, it appears to be split into mirror images by the y-axis. So this one is even. And I'll just tell you, these may be, or they will be in a shuffled order, but one of these will be even, one will be odd, and one will be neither. So even is out of the way. Now, for odd, we need to make sure that a function is symmetric about the origin is the phrase we use. What that really means is that the first quadrant, if you go from, so we started with open angles, in the upper right, that quadrant of our grid, the upper right is the first quadrant, the upper left is the second quadrant, the lower left is the third quadrant, and the lower right is the fourth quadrant. So quadrants 1 and 3, the upper right and the lower left quadrants, need to be mirror images in some sense. Okay, they're going to be very similar. There's actually several reflections going on here, but we're looking for those two quadrants, 1 and 3, to be similar, reflections in some sense, and then the second and the fourth quadrants to do the same. So if you're looking at these graphs, question 8 is the one where the first and the third appear to be reflections of each other. It's actually a reflection across the y-axis and the x-axis, but the point is that you can see that symmetry and it's not even. So this one is odd. And this last one, question 7, if we split it down the middle with the y-axis, we have two very different things. And if we look at the first and third quadrants, the second and fourth, there's nothing really similar here, so this one is neither, or neither. All right, we have 3 objectives left. All right, so question 10 is FNB. FNB consists of evaluating and graphing piecewise functions. Evaluating and graphing piecewise functions. So question 10 is evaluating a piecewise function. So we have f of x equals 5x plus 4. There's our first branch, and that's when x is less than 0. And our second branch, 5x plus 8, when x is greater than or equal to 0. So it depends on what our input is. Okay, so I like to number these. My first branch branch and condition here is the x is less than 0. That's 5x plus 4. And the second one is when x is greater than or equal to 0, and that's we use 5x plus 8. So to find f of negative 1, we first have to ask ourselves, well, is negative 1 less than 0 or greater than or equal to 0? And negative 1 is less than 0, so we're going to use 5x plus 4. We're going to plug negative 1 into 5x plus 4. So I'm going to write this down here. F of negative 1 equals 5 parentheses plus 4, and I'm going to replace the x with a negative 1. Doing that calculation, and I suggest you write this down too to show me which ones you're plugging into. That's very important, or evaluating into. If we evaluate 5 times negative 1 plus 4, that would be negative 1. So f of negative 1 equals negative 1. For f of 0, we need to inspect our independent value there, the 0. And is x less than 0, is 0 less than 0, or is 0 greater than or equal to 0? Well, 0 is greater than or equal to 0. So I'm going to use the second function for this. So this is f of 0 equals 5 parentheses plus 8. And I'm replacing the x value with 0. So evaluating 5 times 0 plus 8, that is 8. So that f of 0 equals 8, and that's what I'll put in my box. The last of these, we have f of 2, and we need to say, is 2 less than 0? No. Is 2 greater than or equal to 0? Well, 2 is greater than 0. So I'm going to use the second equation again. So f of 2 equals 5 multiplied by x plus 8, and that x will be replaced with a 2. So 5 times 2 plus 8, and that will be 18. So f of 2 equals 18. All right, for question 11, we want to graph a piecewise function. So we have a multiple choice set of grids, and we've got this function. F of x equals x minus 2 if negative 3 is less than x is less than or equal to 2. And then f of x is equal to negative 2x plus 6 if x is greater than 2. So what I'm going to do is make a table for each part of this. I'm going to draw a t-chart with x for my x column and x minus 2 for my y. And then I'm also going to draw one for x is my x column and negative 2x plus 6. Now, the big thing here is that we have to choose the right x values. We have to pick x values to evaluate. And again, we choose ones that will work for the first branch and choose values that will work for the second. So we need to pay attention to those restrictions. So the first one, the x minus 2, was if negative 3 is less than x, is less than or equal to 2. So I'm going to use both of those endpoints. I'm going to choose x of negative 3 and x of 2. Now, because those values fit for that branch, I'm going to plug those into x minus 2. So this would be negative 3 minus 2, that's negative 5. And 2 minus 2, which will be 0. So on my grid, and I'm going to draw my own down here, I'm going to have the point -3, -5. So 2, 3, down 1, 2, 3, 4, 5. It's the point -3, -5. Now that's going to be an open dot. An open dot because the function, when the if x is conditions there, it says if -3 is less than x. So that means it's an open dot because it's not an equal to, it's just less than. So -3, -5, I'm going to put an open dot. And then at 2, 0, that was the second point I had. At 2, 0, I have a closed dot, and those two will be connected. Now we might already be able to remove a few of our graphs. Now for the second branch of this though, I'm going to take the condition here. F of x is equal to -2x plus 6 if x is greater than 2. So I need to choose 2, that's an endpoint, and a number that's larger than 2. So I'm going to choose, I don't know, 4. So I'm going to plug 2 into as x for -2x plus 6. So -2 times 2 plus 6, that would be 2. So I have the point 2, 2, and that is going to be an open dot because the condition there was x is greater than 2. So the point 2, 2 with an open dot. And then I'm going to take my chosen x value of 4 and plug that into -2x plus 6. So -2 times 4 plus 6, which will be -2 if you do that calculation. So I have the point 4, -2. And I'm going to go to that point and make it a closed dot. And again, connect 2, 2 with 4, -2. And in fact, that's going to decrease forever going to the right because x is greater than 2 is going to happen as we go. Those 2 points show us the pattern there. And that clearly makes our second graph the correct one. So again, I've been describing this graph I'm drawing. That's the one that matches what I see there. Right, the last two objectives we have involve linear functions. So in question 12, find the equation in terms of x of the line through the points -1, -5, and 3, 3. So in order to find this, there are a few things we need. I'm going to write the slope formula. M equals, we have a fraction of y2 minus y1, and the denominator is x2 minus x1. That is our slope formula. So we need to find the slope. But first, I need to label my points. So -1, -5, I'm going to call those x1 and y1 respectively. And the point 3, 3 will be x2, y2 respectively. How we label that is sort of important. So let's match those values into our slope formula. So our slope is y2 is 3 based on our labeling minus y1, which is -5 based on our labeling, and then divided by x2 minus x1. So x2 is 3, the way we labeled that, minus x1, which is -1 based on our labeling. Always double check that. Your y values should be on top, the difference of those, the subtraction of those, and our x values will be in the denominator. Now you may notice that the formula has minus signs in it, but we have some negatives. So we could write that as 3 plus 5 as a numerator, divided by 3 plus 1. This is something we're going to do several times in this question. So we'll simplify this fraction. That would be 3 plus 5 is 8. 3 plus 1 is 4. So 8 divided by 4 is 2. So our slope is equal to 2. Now here's where our labeling is going to be important, because we're going to use another form of this called the point slope form. And it is y minus y1 equals m parentheses x minus x1, close parentheses. I'm going to use x1 and y1 along with my slope to put this together. So the point -1, -5, and a slope of 2. So I'm going to have y minus y1, which is -5. Okay, so instead of writing y minus -5, I'm going to write y plus 5. So two negatives will make a positive, equals 2 parentheses x minus x1. My x1 is -1. instead of writing x minus -1, I'm going to write x plus 1. Now finally, I'm going to distribute, well, almost finally, I'm going to distribute the 2 on the right-hand side, the 2 times x plus 1, to make that 2x plus 2, and that is equal to y plus 5. The last step is going to be to subtract 5 from both sides to isolate the y. So that'll be y equals 2x minus 3 because we combine a 2 minus 5. Now I'm going to write this in here. My blank says y equals, so I'll write 2x minus 3. Again, remember that the work that I'm showing is, I think, the bare minimum. This is the sufficient or a sufficient amount of work to show that you know what you're doing. So make sure you're showing those same amounts of work. Now our last objective is to determine if two lines are parallel, perpendicular, or neither. And we have given below are descriptions of two lines based on a rectangular coordinate system whose x-axis and y-axis share the same length scale. Line 1 is negative, no it isn't, sorry. Let me say that again. Line 1 is 14x minus 11y equals 9. And line 2 is negative 12x plus 4y equals 9. Now, I'm going to write this over again. 14x minus 11y equals 9. And I'm going to isolate y. So I will subtract 14x from both sides to result in negative 11y equals negative 14x plus 9. And then dividing by negative 11 on both sides. So every term divides by negative 11. That becomes y equals a positive 14 over 11x minus 9 divided by 11. Now the important thing here is the slope. The slope is 14 over 11. So hold on to that for the first line. Now for line 2, I'm going to isolate y in the exact same way. So this will be negative 12x plus 4y equals 9. We'll add 12 to both sides, or add 12x, that is. Add 12x to both sides. So that we have 4y equals 12x plus 9. And to isolate y, we'll divide every term by 4. So 12x divided by 4 is 3, so 3x, and plus 9 over 4. Now, finally, we need to make the determination. Are these two lines parallel or perpendicular? Oh, actually, let me write that. The slope of my second line is equal to 3 because it's 3x plus 9 over 4. On the first line, it was y equals 14 over 11x minus 9 over 11. So that's my 14 over 11 is our slope there. So we want to compare these two. If these two values are the same, we have a parallel system. Okay, so our first option is line 1 is parallel to line 2. Well, 14 over 11 and 3 are not the same, so these are not parallel. Cross that off. Now, perpendicular, for line 1 to be perpendicular to line 2, they have to be opposite reciprocals. So that means one of them must be positive, one must be negative, and they are, well, one of them is a quote, flipped version of the other. So for instance, 1/2 and negative 2, those two are perpendicular. Reciprocals and they're opposites. Well, 14 over 11 and 3 are not opposites or reciprocals, so line 1 is not perpendicular to line 2. And that leaves us with one choice, and that is line 1 is neither parallel nor perpendicular to line 2, and that is our correct answer. Now again, many of these questions require some work. Several of them do not. Keep track of what you're doing with each one of those and make sure you do submit work, because that is how you're going to get your ratings. All right, I hope that this helps you prepare for your objective check over FN1 through FNC. Good luck.